Once more unto the breach, dear friends, once more. This time, we're going to prove that Evan Ferguson is the third youngest player to start a competitive game for Ireland with SurrealDB. Founded only a year ago, SurrealDB is a graph database developed in Rust. Version 1.0 was released in September 2023, and it has 24,000 stars on GitHub. Shout out to Jeff from Fireship.io as well for publishing 2 YouTube videos about it. A multimodal database, SurrealDB allows developers to store data on tables and query it with an SQL-like language named SurrealQL. As a graph database, values on one table can point directly to entries on another, allowing queries to retrieve values from the second table using dot notation. This chapter is going to follow the same pattern as the MongoDB chapter. Install the database, import the data, then create and run the query to prove the statistics. First, install SurrealDB from surrealdb.com, and once installed, start the server with the command on screen. I'll leave it in the description for you to copy and paste. Note that you may need to add the SurrealDB executable to the path for the command to run successfully. Once the server is running, open a second terminal and run the surrealimport.js file to populate the database with data from the levels, countries, players, and games JSON files. Let's start with a simple query to confirm the data has been loaded correctly. Select all players from the players table. To execute the query against the database, use the command on screen. You can see all the entries on the players table here, but it's a little difficult to read, so include the pretty parameter in the command line to pretty print the results. If you look at the ID field, you can see that the table name is prepended to the ID value of each player object from the JSON file. Now, let's find Robbie Keane's entry on the table by adding a where clause with his player ID, players:369. Running the query now shows the record for the former Ireland captain. Now let's find his first competitive start. Write a select query from the games table where the isCompetitive attribute of the level object is true and the starting11.player values contain the ID of Robbie's entry on the players table, which is players:369. As we've seen in previous chapters, the results will need to be ordered by the date attribute in ascending order, and by limiting the results to 1, we'll get the first time the striker was named in the starting 11 in a competitive game. You'll note that, despite the game object not including the level object, its isCompetitive attribute can still be referenced directly in the query. This is due to the graph database nature of SurrealDB. Any field that is the ID of an object on another table points directly to that object and allows its values to be referenced using dot notation. Run this file again, and unfortunately it fails. At the moment, the SurrealDB command line interpreter expects a query to be on a single line, but that makes the SurrealQL file impossible to read. The Unix stream editor command sed can be used as an intermediate step to replace the end-of-line characters in the file with spaces using a regular expression, before piping the results to the interpreter. And now the file is executing correctly. Not every field is needed for the final results table, so replace the asterisk with the date, level.name, hometeam.country.name, hometeam.scored, awayteam.country.name, and awayteam.scored fields. There's the Croatia game from September 1998 that we've seen in the 2 previous chapters. As you can see, the selected fields are retrieved as embedded objects, so add an appropriate name to each field in the query to make it easier to access, and run again to see the difference. Having these values as attributes in the root of the result document will make things easier later on. Now that we can get the first competitive start for one player, let's get it for all players, i.e. all entries on the players table. To do this, add the current query as a subquery to the select all players query from the beginning of the chapter, and name the result as first competitive start, consistent with what was done in the previous 2 chapters. One change is needed for the first competitive start subquery. Since it's using Robbie Keane's player ID, that needs to be replaced with a reference to the ID value from the parent query. Run the query again, you can see that each player that has started at least one competitive game for the Republic of Ireland now has an embedded array with one item, that player's first competitive start. The split clause can be used here to combine the object in the array with the parent player object, similar to the unwind aggregation in MongoDB. This also has the side effect of removing any players who have an empty first competitive start array, i.e. a player who has not yet started a competitive game. If you run the query now, you'll see that the results are composed of players who have been named in the starting 11 of a competitive game at least once. As we've seen in previous chapters, player objects that do not have a date of birth attribute need to be filtered out, so add a where clause to remove them from the result. The query is now almost complete. In the final step, we're going to use this query as a subquery, then clean up its results to be more readable. Concatenate the player's first name and surname, format their date of birth and the date of the first competitive start to be human readable, subtract their date of birth from the date of their first competitive start to calculate their age, then display the details of their first competitive start appropriately. Finally, sort the results by the newly calculated age field and limit the results to the top 20, as in the previous 2 chapters. Running one last time gives the same results we've seen previously, but Robbie Keane is the youngest player to start a competitive game, Kevin O'Flanagan second, and Evan Ferguson third. Before finishing, I'd like to show you the same results using SurrealDB's built-in REST server. Open the REST client of your choice. I've been using hopscotch.io recently, but Postman, Rester, RESTman, Advanced REST Client, etc. should all work fine. Select Post as the method and enter the address as http localhost:8000/SQL. Select text/plain as the content type, then paste in the query to the body. The request header values will follow the parameters used to run the query. NS and DB for the namespace and database values, Irish and international respectively, and set the accept header to application/JSON. For authorization, select basic and use root and root as the username and password, the same values as in the server startup command, and click send to process the query. The same results we saw earlier will appear in the response body here. And that, finally, was 3 different ways to calculate the same statistic. Are there any other ways to generate statistics that you'd like me to explain? Let me know in the comments below. Please remember to like, share and subscribe and turn on that bell notification. Take care and I'll talk to you soon. And as always, have fun.